Hello, you're welcome back. All right, so we'll continue from where we'll stop. Now we are going to be looking at exponential equation, okay? And of course, as the name implies, exponential equation is simply equation in indices, okay? So it's either you call it exponential equation or you can also call it indicial equation, okay? Equation in indices. All right, so now, so it simply means that any equation of the form a raised power x equal to b raised to power y, okay, can be regarded as an exponential equation. Why? Because the entire expression is in exponent, okay? So now we are going to be looking at different method of actually solving exponential equation, and here are the three methods, okay, that we're going to be considering in this tutorial. We'll look at a method of equating powers, then the method of substitution, and the method of logarithm. Now all this method, okay, depend on the nature of the exponential equation, okay? So you use a method depending on the nature of the exponential equation. So now let's start with the very first, which of course is a substitution method, equation of powers. Okay, now as the name implies, so all we do in this method, okay, is we only equate powers. That means we disregard our base, then we equate the powers. Now let me give you a typical example. Okay, so solve the following. Solve the following equation. So a, okay, let's look at 2 raised to the power of x minus 3 equal to 8x plus 1. Okay, so that's B part of the question. Let's look at 2 raised to the power of 3x then plus 2 equal to 1 all over 16. Okay, so now these are the equation that we can solve by equating powers. Okay, now why can we solve this by equating powers? Now you can solve an exponential equation by equating powers only if, okay, the base of both sides of the equation is the same. Okay, they have the same base. Other side of the equation have the same base, so the base can cancel out. That is the only condition. When the base of the other side of the equation is the same, then you can cancel the base and then equate the powers. So in this particular equation now, which of course I'm starting with a, so I have 2 raised to the power of x minus 3, okay, then times. Now what I'm going to do, you know exactly what I'm going to do with 8, okay? I'm going to please pardon me, equal to, right, I have to transform this 8 to an index form, right? So transforming 8 to index, that's going to be 2 raised to the power 3, you know that already. Then of course times x plus 1. So as you can see, the base at either side of the equation is the same, so the base cancels out, then I can now equate the powers. So this is the only condition. So I'm having x minus 3 is equal to let me open this bracket, 3 times x, that's going to be 3x, then of course plus 3. So I have to collect like terms together. So how do I actually collect like terms together? So I'm gonna have, okay, basically let me take plus 3 to the other side. I'm gonna have minus 3 plus 3 goes over, that's still gonna give me minus 3 equal to, now I'm having 3x S comes over here, that's going to be minus x. So I'm going to have minus 6 is equal to 3x minus x, that's going to be 2x. So that means my x now is going to be equal to minus 6 divided by 2. So which is minus 3. So my x is minus 3. Okay. So B part of the question, let's do justice to this one. So invariably now in this case, I will do the same. 2 raised power 3x plus 2, okay, is equal to, of course, I'm going to change the 16 to an exponent. Alright, so now that's going to be 16 sum is equal to 2 raised to power 4. 2 times 2 is 4, 4 times 2 is 8, and then 8 times 2 is 16. So 2 multiply itself into 4 times. Okay, that is 16. Alright, so now, of course, you know very well that I can't equate powers. Why? Because this is reciprocal. I have to resolve this reciprocal first. So let's resolve the reciprocal. It's going to be 2 raised to power x plus 2. Of course, reciprocal, if you can remember. So I'll take the 2 up, then the power now becomes negative. So now the base is the same both sides of the equation. So I can take away the base, then of course equate the power. So I'm having 3x plus 2 equal to minus 4. So collecting like terms together, 3x is going to be equal to minus 4, then minus 2. So 3x is going to be equal to minus 6. So my x now is going to be equal to minus 6 divided by 3, which of course is minus 2. So that is method of equating a power. So once you're able to express that particular indices, okay, to have the same base at both sides of the equation, then you can equate the powers. Okay, so now let's go to the second method, okay, which of course is a substitution method. When do we apply substitution method? Substitution method, okay. Now you apply substitution method to an exponential equation that is of the form, in which if I introduce a simple substitution to it, it can be converted to a quadratic equation. Okay, then after solving the quadratic equation, now I will now get find my known. All right, I will give you a typical example. Now if you see example, okay, see a question like this: solve, okay, solve 25x plus 2 into 5 raised to the power of x, then minus 3 equal to 0. So once I see this kind of exponential equation, I know very well that I will have to apply substitution method. The reason being that if you look at this exponential equation, it looks more like a quadratic equation. Okay, this is how this can actually be transformed like it into a quadratic equation. Okay, let's let me express 25. Okay, let me express 25 in an index form. So 25 already I know is 5 raised to power 2. So I have 5 raised to power 2x. Then here I'm now having 2 times 5 raised to power x. So the power of the exponent of 5 is reducing. Here it is 5 raised to power 2x. Now it has reduced to 5 raised to power x. Then here now I'm having a constant value. Okay, so once you see an equation of this exponential equation of this nature, you know very well that you apply substitution to solve it. what is the substitution you apply? You introduce a variable use, okay, by saying let y represent 5 raised to power x. Since 5 raised to power x is actually the index that carries the unknown or the variable I'm actually looking for, okay. So if y is equal to 5 raised to power x, that means 5 raised to power 2x will be y squared. Yes. Why? Because 5 raised to power 2x, okay. 5 raised to power 2x, you know very well that is 5 raised to power x times 5 raised to power s. That is y times y. So which of course is y squared. So here now that's gonna be what I'm gonna have is y squared then plus 2 into, okay, 2 times y then minus 3. So as you can see, by this simple substitution, I've actually converted this particular exponential equation to quadratic equation. So it's after I must have solved this quadratic equation that I will now come back to get the value of my x. So first I need to get the value of y by solving this quadratic equation. Well, okay, we can go by the general formula, okay, much easier. Let's go with general formula. Of course, general formula of solving this, of solving quadratic equation, that's going to be minus b plus or minus the square root of b squared, okay, minus 4ac all divided by 2a. So here we go. So y is going to be equal to b. Of course, there's the coefficient of y, you know that already, okay. So the coefficient of y is 2. So I'm going to have minus 2 plus or minus b squares. That is going to be 2 square minus 4 times plus my a. 4 times my a is the coefficient of y square, okay. Coefficient of y square, and the coefficient of y square is 1. 4 times 1, then of course times c, which of course is minus 3, okay, then divided by 2a, 2 times 1. So I believe you know how to do this. If you don't know how to use this automatic formula, you can still go to our tutorials, okay. Go to this. If you go back, we actually treated equations and we solved quadratic equations, so using the formula. So you can go to that particular video and go through it again. So now here we are. So y now is going to be equal to, let's solve this bracket. This is 4. 2 squared is 4. 4 times, of course, minus times minus here is plus. So I'm having what I'm having here are the, okay, let's start with this one first. Minus 2 plus or minus, so I'm having 4 plus 4 times 1 is 4. 4 times 3 is 12. So 12 plus 4 is 16, all right. So everything inside this square root is 16, then divided by, okay, plus or minus, then divided by 2. So of course you know very well that my answer, my y will you two answer, one for the plus and the other for the minus. So my y is either minus 2, the square root of 16 is 4, all right. So minus 2 plus 4 all over 2, or my y is gonna be minus 2 minus 4 all over 2, but I will only use the one that will give me positive value. Why? Because in this index and my base it shouldn't be negative, okay. So the only one I will use is this minus 2 plus 4, which of course is 2. 2 divided by 2 is 1. So my y is equal to 1. So having gotten my 1, I can now get my x. Remember, I actually, okay, substituted, okay, y is equal to 5 raised to power x. So how do I now, since y is 1, okay, my y is 1, that means 5 raised to power x is equal to 1. Now the question is now that the question is, how do I actually get my x? Okay, that means I have to change this one to an index form, right? Okay, so in indices or exponent, any number that's raised to the power of 0 is always 1. So invariably now, 1 here is in an exponent is something as 5 raised to the power of 0. Okay, 5 raised to the power of 0 is 1. So that way you know very well now that the base is the same both sides. So base cancels out. So that my x now is gonna be equal to 0. So that is substitution method. Okay, I can still look at another example. Let's look at another example. Okay. All right, so we'll look at another example. So I'll pick some other question. Okay, still on substitution method. So question that I can. Okay, so I have 3 raised to power 2x minus 6 dots. That's this dot represent times row. Okay, 6 dot 3 raised to power x. Okay, then plus 9 equal to 0. So of course I can now to solve this. Okay, solution. Okay, solution. I can now introduce a variable y. Okay, let y be equal to 3 raised to power x. So invariably now 3 raised to power 2x will be y squared. Then minus 6y. Okay, plus 9. Okay, now there's another way of actually solving this. Is just by factorization. Okay, if you don't want to use almighty formula, so I multiply the first term and the last term, then I get the factors. That's going to be 9y squared. So I split this 9y squared into its factors. Of course, the factors of 9 is 3. 3, 3, that's 3y. So I have to add a sign, either plus or minus sign, so that when I add it together, it should give me the middle term. So the sign I should add is minus 3y minus 3y, because minus 3y minus 3y will give me minus 6y. So I can now replace, okay, the middle term minus 6y by minus 3y minus 3y, okay, then plus 9. So I now have 4 times. Now I have to factorize, group it into 2, okay, then factorize the binomial expression individually. So what is common between y squared and y? That is y. So I factorize this as, okay, so y, I factorize y, then y minus 3 now will not be inside the bracket. What is common between minus 3, y plus 9? Okay, the common factor is minus 3. So I have to open a bracket, okay? The other factor, I put it inside the bracket. Then the other factor of 9, since 3 is already outside, that's still going to be minus 3, okay? Of course, you now have to use minus 3 because minus 3 times minus 3 will still give me 9. And another thing too is this: once you've gotten your first bracket, the second bracket must always be, okay, equal to your first bracket. So don't forget, all is equal to 0. Okay, so now let's now factorize. Y minus 3 inside the bracket is common, so I want to factorize that out. So I have y minus 3. Okay, then of course open bracket y minus 3 equal to 0. So from here now, you know very well that for me to get my y, I can simply say that y minus 3 is equal to 0, or my y minus 3 is equal to 0. So that gives me y now to be equal to 3. Okay, minus 3 goes over, becomes 3. So I've gotten my y now, I can now get my x. Okay, now don't forget that originally y is equal to 3 raised power x. So since I've gotten my y is equal to 3, right? So 3 raised power s is equal to 3. And of course, 3 is not as 3 raised power y. Okay, the base cancel out so that I now have that my x is equal to 1. Okay, so you can go through it over and over again and you get used to it. So that is that for substitution. Now let's now go to the method of logarithm. When do you apply the method of logarithm? You apply the method of logarithm when you cannot use substitution or even equating powers to solve uh, that particular exponential equation. Yeah, there's some complex situation like that. Okay, that you have to employ logarithm method to solve. Okay, let's look at some typical example. Okay, so let's look at a situation where you're being asked to solve the equation 5 raised to the power of 3x minus 2, okay, equal to 1 all over 108. Okay, now I know very well that if someone sees this particular question, okay, it will look like something, it look like an equation that I can solve with equating of powers, but it can't work. Why? Because of the right hand side of the equation. So there's no way I can there's no way I can express 108 as an index whose base is actually 5. It's not possible. Okay, and there's no way I can actually transform this into a quadratic equation. So at this point now, the only method is to use logarithm to take the log of both sides. Okay, so the first step, okay, in logarithm is just to take the log in base 10. Take the log in base 10, which of course is natural logarithm. Okay, log in base 10 of both sides. So I'm gonna have take the log. So that's log of 5 raised to the power of 3x minus 2. Okay, even if I don't put the base of 10. Okay, anytime a log is written without the base, that is by default. Every log that doesn't have base is in base 10, so please take note of that. So I have to also take the log of this also 1 all over 108. So now, by the law of logarithm, you know power of logarithm goes at the back of the log. So that means the power of this log 3s minus 2, okay, goes at the back. So now I'm left with log 5, okay, equal to log of 1 all over 108, okay. So now my answer will always be an approximate value. Okay, one peculiar thing about using a logarithm method is your answer will be an approximate value. Why? Because you will find the log of the values. Okay, so invariably now 3s minus 2 is going to be equal to log 1 all over 108, then divided by log 5. Okay, so now this is now where we use calculator to simplify. So you can use calculator to find the value of those log, or you use your 4-figure table. Let's look at the calculator. Okay, here we go. So first of all, I'll do 1 all over 108. So I have 0.0092. Let me find the log of that. Okay, So I can now have to find the log of what I have there. Alright, so the log of that actually gives me minus 2.0 approximately. So now divided by the log of 5. So this gives me approximately 0.7. So invariably now, so I'm having 2.0 divided by 0.7. Okay, so minus that's approximately 2.9. So to get x now, I'm gonna have minus 2.9 then plus 2. So of course minus 2.9 is plus 2 is gonna give me minus 0.9. Okay, so my x now is gonna be equal to minus 0.9 divided by 3. Okay, so of course you know what that will give. That's 0.3. So my answer now is minus 0.3. Okay, so that is when we apply logarithm methods to solve exponential equation. All right, so I hope that is well understood. Okay, so we're still gonna look at more questions, right? So see you in the next video. Thank you very much.